Hello everyone, EdGO here. I want to update you regarding the parts I ordered, the magnetron and fuse. I already ordered them and it will arrive soon. While we are waiting, I made this new tutorial about testing the high voltage transformer of a microwave oven. This video shows you how to do so. I removed this high voltage transformer from the oven we are trying to repair. These are the primary winding terminals. These secondary winding terminals connect to the magnetron. This terminal goes to the high voltage capacitor. This is the high voltage terminal. Now I am testing the transformer using a digital ohmmeter. First, I test the primary winding. Set the digital ohmmeter range to 200. Then connect the probes to the primary winding terminals. It shows a low resistance of about 4 ohms. This is a good test. Next, I test the terminals that connect to the magnetron. It shows almost zero resistance, like a short circuit. This is also a good test. Next, I check the previous terminals with respect to ground. Set the digital ohmmeter to 2000 K range. It shows an open circuit. This is a good test. Then I test the high voltage terminal with respect to ground. I get a resistance reading of about 200 ohms. This is also a good test. Now here's a question. Is it possible to power on the high voltage transformer to test if it is indeed stepping up the voltage? Yes, that is possible. You just need to apply a very low AC voltage to the primary winding terminals of the transformer. Let's say, for example, the high voltage output is 2000 volts, while the input is 220 volts. Divide 2000 by 220 to get the ratio, which is equal to 9. This means 220 volts is step up 9 times to get 2000 volts at the output. Now, to lower the input voltage, we can use a step-down transformer with an output voltage equal to or less than 6 volts. We apply that voltage to the input of the high voltage transformer. Then using the ratio, we multiply 6 volts by 9 to get the output of 54 volts. So now it is safe to test the output voltage. This universal AC to DC adapter has a step-down transformer inside, and this is better because it has a winding for a 1.5 volts DC output. What I did here is to bypass the rectifier circuit, isolate the two terminals of that winding, and connect two connection wires. Here I am removing the cable of the AC adapter. I am removing the common wire on the secondary winding. Now I'm soldering the two connection wires to the 1.5 volts DC winding terminals. Here I am testing the coil, showing a resistance of 2 ohms, which is good. I am putting everything back to the casing. Now I plug the AC adapter and test the actual AC voltage of this winding. And it shows a voltage of 3.5 volts AC. Then unplug the AC adapter for now. It's time to connect the AC adapter to the high voltage transformer and measure the output voltage. Take note that we are only using the step-down transformer of the adapter. Connect the adapter to the primary winding terminals of the high voltage transformer. Then connect one probe of the AC voltmeter to the HV terminal and the other probe to ground or body of the transformer. Set the range to 1000 volts AC. Now I plug the AC adapter back in the outlet. Let's check the voltage at 1000 volts AC range. This is 200 volts and 100 volts. And the needle shows less than 50 volts. Now I set the voltage range to 250 volts. This is 250 volts AC range and the needle shows about 35 volts. Now I set the voltage range to 50 volts AC. The final reading is 35 volts. So this means that the high voltage transformer converts the 3.5 volts input into 35 volts output, and it shows a ratio of 10. And the transformer is working just fine. Thank you for watching. If you like this video, please subscribe to my channel for more. Click the bell icon to get notified about my upcoming tutorials.